Okay, hello everyone and welcome to the week 4 lecture, and it's going to be about the theory and the application of the computer-aided design. So in today's lecture we're going to have 3 sections, and in the first video I'm going to cover the introduction and the computer-aided design, where we're going to discuss the fundamentals and the applications of the CAD in the industry. The second part of the video, or the second video, is actually about the teamwork in the engineering design project, which I told you earlier last week that we need actually to start forming the teams, and we found out that we actually have 60 students, so that's means we can divide the work between 3 students per group. We go to the introduction. First, the learning objective is going to be first understand the fundamentals and the applications of the computer-aided design and computer-aided engineering in the industry, and also to understand how to start a teamwork for the engineering design practice, describe how to manage the design project, describe the design brief and the mission statement, and develop the design specifications, and the demystifying the design process. The revisit engineering design process. The design in general is highly innovative process that seeks to satisfy some needs. So the design can be for either a personal expression, like the artists, to satisfy one's own needs on the desire for the expression. The second design can be for the product or the process development, which is going to be a technical issue to serve some of the useful purposes and functions. The engineering design in general is a combination of the aesthetics and the functional design. However, the aesthetics is not going to be always necessary. Broadly, we can split the engineering design into 2 categories. First, the product design, and the second one is going to be the process design or the system design. The 4-phase process is going to be first, what are the requirement developments, like we need to recognize the need, identifying the problem, and define the requirements. Then we're going to create the conceptual design, where we're going to generate an innovative concepts or select the best concepts. Third stage is going to be the detailed design. We need to identify what are the product layout, the material selection, the system simulation, the prototype and the testing, and the design documentation. Finally, we are going to go to the last stage, which is going to be the production, where we need to decide what will be that type of manufacturing, the production volume, the supply selection to get the final product. That's when we go actually forward. Every stage can set a feedback to the one before. So that means if I'm going to get the recognize everything, we identify the problem and define the requirements and make the conceptual design, we can simply feedback the previous stage to update the parameters. So we can always go backward and forward until we're going to have the perfect product. After we got the product, even at this stage, we can contact the customer and see if we need to modify any of the design stages. Now, let's talk about the fundamental of the computer-aided design, or the CAD system. Now, everybody knows the CAD system simply as the geometric shape only. Now, that's part of the general CAD definition. So the computer-aided design, or the CAD, is also sometimes called the computer-aided design and drafting. The drafting actually is the process of making the CAD model. This is the process of digitally creating design simulations of a real-world goods and products in 2 or 3 dimensions. The CAD often is going to be completed with skill, precision, and physics properties to optimize and perfect the design, often in a collaborative manner, like a teamwork, before manufacturing process to be done. Now let me give you a simple example about what we're talking about here. Just imagine that you're designing a bottle for a soft drink. Okay, now you can make different designs on your mind. You can make a different design on the CAD software to make a representation for the shape. The thing is, okay, now does this design actually is going to be perfect for the work? For example, if the base is going to be narrow, that means I'm going to be still probably on the table. If the bottom is going to be weak, that means it's going to be blown due to the effect of the carbon bubbles we have on the solid drink. Is able to take the positive or negative pressure? Is the shape is going to be good to be handled? So all these stuff, the heat transfer through the walls. So all this stuff should be actually taken into consideration while we're doing the design procedure, and all can be tested if we know how to control something like stress analysis by doing finite element analysis, or something like the computer fluid dynamics. So the CAD allows the engineers and the designers to create, modify, analysis, and optimize the design, and thereby improving the overall quality and the productivity of the manufacturing process. The two-dimensional or 2D drawings and the three-dimensional 3D drawings models can both be produced using the CAD software. The CAD can quickly bring new, unique products to the market. And compare the conventional pencil on paper methods of the engineering and design, manual drafting, CAD software has supplemented the T-squares and the projectors employed by the past designers. Now, the components of the CAD system are the CAD software and the CAD hardware. The CAD software package is a software like the SolidWorks, the AutoCAD, the CATIA, the Korea, etc. And this will allow the users to create a design from scratch or modify an existing design. The CAD hardware is a powerful computer with a powerful graphical card and GPU, actually that's CPU, user interface or the graphical user interface, GUI, to display the CAD geometry and collect the user inputs. So the generic CAD process is first you need to do once again the recognition of the need, and then you have to give the problem definition. Now we are going to start with the synthesis, the analysis, the evaluation, and the presentation. So at every stage in the synthesis part, you're going to have the geometric modeling to be done. In the analysis, you can do the engineering analysis, the evaluation, design review, and the evaluation. And then for the presentation, you can do the automated drafting like the one we did in the class with the CAD model, 3D dimension, engineering drawings. Okay, so all these stuff are going to be within the drafting process. The CAD product development in the mechanical engineering can be something like we have two stages. We have the pre-dimensioning one, like the components and the tool dimensioning per the computer-aided engineering, the structure, the fluid flow, and the process simulation, where you can find these, for example, the strain and dynamic strength, the rigidity and stability, the lifetime analysis, the vibration analysis, the crash analysis, and the casting simulations like the molded flow. So you are going to give it to the stage of the pre-dimensioning, and this will be simply going to pass it to the CAD design component geometry, where it's going to give some feedback to the components and the tool dimensioning where the computer-aided design. Then, if passed, we can go to the next stage. We can make a comparison between the CAD design component geometry and the component and the tool dimensioning per the KAE to have a comparison in the tool design by the CAD or computer-aided engineering, geometry, rheology, heat balance, and strength. For the generic 2 to 3D CAD using the AutoCAD, once again, you can simply start with manual drawing on the paper, like what I do usually on the whiteboard. Then you are going to send it to the AutoCAD drawing. And then we are going to give it a setting, like for example, again to do the units limits, the grids, the snaps, and the object snap, whatever the thing is, layers organization, layout definition, and extra. And after we do the setting, we can simply do either the 2D design, like 2D elements, and the edit the elements, and then you can send it to the annotation and dimensioning for again to present as an output. The other way we can do it is 3D based solid and with 3D operations, and then you can once again send it to the annotation, dimensioning, and then you're going to send it as an output. The output can be a CAD drawings, can be drawings file DXF, it can be a plot like the paper or the PDF, or it can be a 3D printed file by making an STL file first and then sending it to the additive manufacturing. So again, for the types of the CAD, we start with 2D CAD, where it draws fundamental geometric shapes like lines, rectangles, circles, and all are going to be in XY plane. Uses the text, dimensions, leaders, and the tables as an annotation on the drawings. Has a library of the geometric images, the capacity of design to bezier curves, splines, and the polylines, the ability to specify the hatching patterns, and the ability to generate the bill of the material. Now, by the way, we will learn how to do the bill of the material because this will be very important things in the product life management analysis later. We're going to learn in the week number, I think 9 and 10. So we can also have the 2.5 dimension CAD. This is a medium level CAD between the 2D and 3D. It depicts the depth of the parametric objects and depicts the heights or the thickness or the depth of each place of the object using the contour map, and only going to draw in the XY plane too. So it's going to be 2.5, but it's not going to go to the Z direction. Now the 3D CAD is going to do that. So the 3D CAD is the most popular CAD with a powerful computer processing power and graphic display capabilities. It produces a realistic representation of the design object, enabling the designers to address the potential issues earlier and with a lower production costs. It provides multiple modeling ways like the surfaces, the wireframe, and the solids. Draws in the XYZ coordinated system. Now, how we can have a CAD as a files? We have different file formats. The neutral file formats are going to be used, will allow the sharing between the various softwares. So, for example, we're going to have it as one of the following files, like the STIP, the IGES, the 3D PDF, the GT, the STL, the ACIS, the Parasolid, and the QIF. If you're going to do it with the SolidWorks, you can open it with the AutoCAD, or you can open it with the Catcher. Okay, so, and vice versa. While if you're going to save it as SolidWorks part, that's it. It's only going to work with the SolidWorks software. And that's why it's not going to be considered as a neutral file formats. So next time, if you're going to try to make a drawing or a CAD model with the SolidWorks and you want to share it with a company, just be sure that you're going to save it in one of the following format as well beside the SolidWorks. So if they don't have the SolidWorks, they still can open it. So we have what we call the native file format, which is going to be the described file types exclusive for a particular CAD application like the SolidWorks files. Only allow using the specific CAD software and cannot be shared by the others. Now, the application of the computer-aided design or the CAD. It's used by architects, engineers, drafters, artists, and other to create position drawings or technical illustrations. It's a comprehensive tool that enables the designer to consider and analyze every aspect of the product design, from its overall structure to the minute details. An individual tool in the manufacturing process. The application of the CADs can be simply listed as the manufacturing, including the 3D, printing, the dental, the mapping, the fashion, the architecture, the building furniture, the automotive sector, and the interior design. Actually, these are just part of it. Now, continue with that. The roles of the CAD in the engineering design and manufacturing are: first, the CAD used in the detailed design phase for the design and prototyping. This will allow for the creation of detailed 3D models of the products. It's going to visualize the final products before the manufacturing and to make any necessary changes to the design. Finally, it's going to create a prototype of the products. Also, the CAD used in the production phase for the production and the quality control. So the programs manufacturing equipment such as the CNC machines to produce the product, checks the accuracy of the manufactured product, ensuring that it meets the required standards and the specifications. Now, the benefit of using the CAD in manufacturing is the cost and the time saving. Because if we're going to do the manual drafting, this will take too much time. This cannot be changed unless we're going to repeat the whole drawings. While if we're going to do it with the CAD, it's going to be much easier. The other thing is the efficiency improvement, because we can control all the manufacturing process by using the computer. The easy communication between different machines and the human, and easy file and data sharing and exchange. Still have some challenges of the using of the CAD in manufacturing, like the software and the hardware cost. So I don't know if you know, but for example, the SolidWorks license, just an example, is going to be some $1,000. So we have a specialized software also can control the machines. Also, it's going to be quite expensive, especially if we're going to connect it to the computers. Also, we need to have a skilled personnel. So the product design process for a car, for example, we are going to have the CAD level to be connected between multiple levels for the automated product design. So we have level 1, level 2, up to level 7. And the level 3, we're going to have the draw of the die development and simulation. That's 3 for the critical parts, just surfaces. Level 4 is going to be the start processing, planning all the parts, pattern, and the casting. The level 5 to level 7 is going to be about the process and the design to build a long lead, build medium lead, to build the tool as a short lead. And then we're going to have the final die development and the tool surfacing, and we're going to go for the home line tryout. So that's it for the first part of this lecture, and we're going to have a separate video for the teamwork in the engineering design process.